Alright, so we're going to finish this last couple slides up here. So this example says, determine the zeros of the polynomial, indicate whether they have order 1, 2, or 3. Okay, so we're going to do all this straight from the equation, and then we'll graph to check. So looking at the equation, it's in factored form. What we want to do is know when this is 0. That's how we determine zeros, when the y is 0. So we'll put that as 0. And we need to solve this. Okay, so how do we set these equal to, we set each of these factors equal to 0 to find that out. So we've got this first factor, negative x equals 0, and that's clearly a solution is when x is 0, and that's the only solution. And since there's only one factor of x there, this is an order 1, 0. Over here we've got this factor, there's 3 of them though, so we've really got x minus 3 cubed equals 0. Solving this, since they're all the same, the only solution here is when x minus 3 equals 0, and that only occurs when we add 3 to both sides and we get x equals 3. Okay, so that's another 0, and there's 3 copies of them, so this is an order 3, 0. Okay, so let's make a sketch of this. I'm just going to do this very rough and taking into account a couple things in a minute. Alright, so let me get an axis going here. Here we go. And let me write out this equation. So it was f of x equals negative x times x minus 3 cubed. Okay, so now you have to imagine if I expanded all this out, in this bracket I get a cubed. Okay, so I get like an x cubed out of this. That's the highest exponent I'm going to get. And then I'm going to multiply that highest exponent I get out of that bracket by an x. So this means this is a degree 4 polynomial. Alright, and it also has a negative leading coefficient. Okay, so I know I have a 0 of order 1 at the origin. It's when x is 0. I have a 0 of order 3 at 3. And those are the only zeros in this equation. It's a degree 4, it's even, so therefore the end behaviors have to end on the same side of the axis. It's a negative leading coefficient, therefore they need to be down here. They need to be doing this in the end. Okay, so I need to come up from down here, and I'm going to cross to these 2 spots. Now remember that an order 1, 0 I just pass through. An order 3, 0 I scoot. So if I come up, I'm going to pass through this. Now I got to turn directions somewhere because I got to come back down and pass through here. But this is an order 3, so I kind of got to scoot across and then continue down. Notice how I drew that. This is an order 3, 0 here. This is an order 1, 0 here. Passes through, scoots along. That's our sketch. One more example here. Last one to take notes on. Okay, for each of these, we're going to determine the least possible degree, the sign of the leading coefficient, the x-intercepts, and the factors, and then we'll talk about when the intervals, the function is positive and negative. Okay, so least possible degree here, let's check this out. We've got a 0 here, we've got 3 zeros, it's got this opposite end behavior. We're looking at an odd degree function. It's got 3 zeros, so I'm thinking degree 3. It's got 2 max mids. So lowest we can say is this is a degree 3. Sign of the leading coefficient is positive. So that's answer 1. Answer 2 is positive. The third answer. Okay, now the intervals where the function is positive and negative. So what we're asking here is when the function is positive, when the function is above the x-axis means it's positive. Up here is positive, down here is negative. So the intervals where the function is positive is the function is above the x-axis from negative 7 through to looks like negative a half. So we're positive. Let me write that down here. So we're positive on the intervals from, now I'm going to use these square brackets to go from negative 7, comma, this is through to negative a half. Okay, so this is an interval notation saying from negative 7 to negative a half, it's positive. It is negative from -1/2 through to, looks like 3.5. It is also positive, so I'm going to go back up here and add. It's positive from 3.5 and onwards, out to infinity. And it is also negative on the other side of this, down here. It's from -7. It's from all the way from negative infinity all the way up to that -7. Okay, so give this one a try. Try this one, doing those same things, and bring this to class tomorrow. Bring.